Hey, it's Dr. J. 6.1 exponential functions today. I'm going to skip all the backstory and just jump right into what the definition of an exponential function is. F of x is equal to a to the x for a value a that must be greater than 0. A is called the base. A note, if you Google this, sometimes we use the letter B for base. Occasionally, I'll use B if I've run out of A's or if I've overused the value of A, but A is such a simple letter that I'm just kind of sticking with it for this one. So that is the definition of an exponential function. We'll start off with some simple examples. The simplest example is probably base 2. So the base is 2. So f of x is equal 2 to the x power. We're going to put off the graphing for today and just play around with the function and get used to how the function operates before we actually start drawing any pictures of this. So we'll do some evaluations to sort of get the ball rolling. Let's evaluate the following. F of negative 3. And we won't stop there. I'm just using that to get started with. So what would the function, if you evaluated at negative 3, be? Well, that would be 2 to the negative 3 power. Notice that x would be equal to negative 3. Now, you need to be careful with negative numbers. Oftentimes, you'll see a negative number, and your brain will start thinking that it's actually negative. The negative number does not mean a negative number. It means a reciprocal. So you have to reset your brain into interpreting this negative power as a reciprocal. So it's not actually a negative number. It's 1 over 2 times 2 times 2, which is 1/8. I probably have room for one more here. How about f of negative 2? F of negative 2 would be 1 over 2 squared, which would be 1 over 2 times 2, which is 1/4. Let's do a few more. F of negative 1, using the same function, continued up here. So 2 to the negative 1 power. Again, the negative does not really mean negative. It means the reciprocal of 2 to the first power. So that would just be 1/2. Zero is a special case. Anything to the 0 power is automatically 1. That's a free answer if you know it. The most common mistake I get on this problem is probably exactly what you could imagine. You see a 0, and you plug in 0, and then you accidentally type in 0. So just try to avoid that mistake. I might as well do a couple more before we put this one to rest. F of 1 would be 2 to the first power. Notice I saved the easy ones for last. F of 2 would be 2 to the second power, which would be 4. And I could keep going. How about one more? I started with negative 3. Why don't I end with positive 3? 2 to the third power, which is 8. And so that's just to kind of get us familiar with how to evaluate or how to plug in values into an exponential function. Well, they're going to be a little bit more complicated than just multiplying by 2. So let's see another example. I'll give you a second to maybe pause and write this down before I erase it. So 3, 2, 1, erase. Example 2, we got f of x is 3 to the negative x power. Let's evaluate a few different values. Let's do f of 2, f of 0, and f of negative 2. Whenever I tell you to evaluate, the inputs will be given. I'm not expecting you to memorize the numbers that we're plugging into the function. Although you'll probably notice a pattern once I get through 4 or 5 examples. You'll be like, hey, he's always using the same types of numbers. Semi-intentional that I do the same numbers over and over again. But to be honest with you, I will give you what numbers you're going to plug in. Be careful with negatives. You are plugging in a 2. But there's already a negative sign out in front of the x. So this becomes 3 to the negative 2, which is 1/9. So 1 over 3 squared is 1/9. One thing I get a lot on the test is somebody will go 3 squared, and then they'll accidentally say 6. Because your mind goes, 3 times 2 and tells you it's 6, and you write down 6, or you type in 6. It's not 6. It's 1/9. Okay. When you plug in 0, notice there's no such thing as negative 0. Negative 0 doesn't make any sense. So negative 0 is just 0. And so there's another freebie, free answer. You get 1. And finally, for the last part, f of negative 2, I'm plugging in a negative 2, but I already have a negative sign outside waiting for me. So a negative 2 is just positive 2. And so now you have 3 times 3, which is 9. You might notice something about this function before I erase it. Just want to take one last look at it. F of x equals 3 to the negative x. You can rewrite it if you like as 1 over 3 to the x power. In other words, one technique that you might find useful, and I'm not mandating that you do this, I'm just telling you that you can do this, you can get rid of the negative right away so that the x is no longer negative. Yeah, this means the same thing as 1/3 all raised to the x power. And now when you do your evaluations, watch. I'm going to keep all my answers, but erase all the work. All right. And notice that had you done it this way, using the rewritten version, so instead of writing it, actually I'm going to use this one. Although these are equivalent, you could say 1 over 3 to the x, or you could just say 1/3 to the x. The tomato, yeah? So I'm going to write it as 1/3 squared using this version here. And look how much easier the problem is. You are a lot less likely to make a mistake if you write the question in a way that makes a little bit more sense to you. And if neither one of these makes sense to you, then I'm sorry. I can't help you. So we have, I'm going to redo all of these. So now we have f of 0, which is 1/3 to the 0. Well, there you go. There's another free answer. You still get the same answer. You're still going to get 1. Here's where your luck runs out. When you can't get something for nothing. So, if some of these problems turn out to be easier, you can pretty much guarantee that later on it's going to bite you. Now this problem just became more difficult. Now you have 1/3 to the -2. So for this particular one, it's probably better just to use the original problem. But, I already opened this can of worms, so I'm going to go ahead and finish the problem. This would be 1 over 1/3 squared. And you might be going, no, don't do it. But I'm doing it. 1/3 squared is 1/9. Yeah, 1/3 times 1/3 is 1/9. And then you have a reciprocal of 1/9, which is 9 over 1, which we all know as 9. So you're going to get the same answer. Check, check, check. All of these should have the same answer, whether you write it as a negative power or whether you write it as a fractional base. They mean the same thing. Okay, in the next example, we're going to find the function f of x equals a to the x that passes through the points the point, actually, it's only one point, 3 and 1/64. So in this example, I'm alluding to the graph. I will draw a rough graph over here just to give you an idea of what's going on. X is equal to 3, and y is equal to 1/64. 1/64 is so small, it's basically touching the x-axis. Put it into a calculator, it's 1 divided by 64, which is 0.015625. It's tiny. Yeah. So you want to find this function. Yeah, so this is what our graph will look like. We're actually going to draw the graphs with detail in a little bit. For now, I just want to get you used to how the function behaves before we start playing around with the graph. So let me go ahead and just put this inside of a thought bubble. You can just think about the graph while I'm doing the problem, but you don't actually have to draw the graph. Okay, you know that I've said this before. A function, when I say f of x, I'm really just saying y. So one suggestion that I gave to you a long time ago, it was probably February or maybe March, where I said, every time you see f of x, why don't you just call it y? Yeah, it's just going to make your life so much easier. And then now, when you're solving the equation, it's very easy to figure out who goes where, right? Y is clearly 1/64. There's no mystery here. And x is clearly 3. So, I mean, everybody comes to you dressed up in exactly the outfit that you would expect them to be in. X always comes first. Y always comes second. You plug them into the equation, and now there's no mystery. I'm not trying to trick anybody here. Okay. Now, there is one unknown, if you want to call that the mystery, but it's really not much of a mystery. You have a cubed is 1/64. So you're going to use one of those mother functions that we learned in the last chapter, the cube root. You're going to take the cube root of both sides. Make sure you do it on both sides. On the right-hand side, you're going to cancel and get your a value. And on the left-hand side, if you have to use your calculator, go ahead. But I know you really don't. The cube root of 64 is 4. All right, I know some of you are going to reach for your calculator and start typing it in. But all you got to do is think for a second. 4 times 4 times another 4 is 64. So there's your answer. Okay. They get worse, but we're still sort of in the beginning stages of the exponential functions. So we'll go easy today. You want to see one that gets a little bit worse? Huh? Yeah? Let me find a nice one. Example 4. Find an exponential function. F of x equals CAX. So I'm adding in a constant, C. And just to be clear, I'm going to put a multiplication dot in between, although oftentimes we omit that dot because we can. Yeah, but if you want to be absolutely clear, you can put the multiplication dot so that there's no ambiguity there. So find this exponential function passing through the points now. So I'm going to kind of kick up the complexity a little bit. 0, -1, and 2, -4. Now we have two unknowns. We have C, called the constant, also known as the scalar. Remember, we learned about scalars in the last chapter. And then we have A, that's called the base. And again, some authors and some textbooks and some Google web pages that you might Google will use the letter B for base. Really doesn't matter. Here's the deal with these. You always want to find C first. If you try to find A before you found C, you're going to end up all twisted up and you're never going to be able to resolve the problem. Okay, so you got to know who's most important. Find the constant, find that scalar value first. Okay, it should be relatively simple. You're going to use this point that contains a 0. Why? Well, because I said so, but there's a better reason. It works. If you try to plug in the other point, it just doesn't work. And I'm just sparing you the agony of defeat. So you're going to plug your -1 in for y. And you're going to plug your 0 in for x. And it's not going to take you very long to resolve this. You're going to immediately get that your c is equal to -1. That's the magic of the exponential function. When you plug in 0, it always kills the base. So you have a to the 0 power. Well, that just becomes 1. So it's gone. Remember, 1 is like, I mean, I don't want to say 1 is nothing, but it sort of is. When you're solving an algebraic equation and you have a 1, you might as well not even have it. It's gone. Yeah? So you just have c is equal to -1. Now that you've found C, you're going to use the other point, the non-zero point, to find A. All right, A is the trickier value to find. C is usually pretty simple. So I've got y equals CAX. I know what C is. C is -1, so I can go ahead and put -1 in for C. Now I don't need that point anymore. And now I can plug in my other point, 2 and negative 4, and solve this sucker for a. You know how to do that. Just divide both sides by -1. Then take the square root of both sides. Last time we did a cube root because the power was 3. This time the power is 2. If the shoe fits, yeah, power is 2, use a square root. If the power was 4, use a 4th root. Square root of 4 is 2. And then a squared and a cancel out. A squared and the square root cancel out, and you just get left with your a value. So we're done. We've got our c. We've got our a. And so our answer is f of x -1 times 2 to the x. Do not combine the -1 and the 2. Keep them separated. Okay? If you really want to be safe, you can put a dot, or you can put parentheses around the 2. Either one of these would be acceptable. But if you multiply them together and you get a -2, it will cause lots of evaluation problems in the future. In fact, the future is now. Let's see an example of that. We might as well just use the function I was talking about. I only need to do one example to get the point across, I hope. Actually, I think this is example 5. So in example 5, I'm using the same problem from example 4, but I'm now going to show you how important it is to keep the -1 and the 2 separate. So when I do my evaluation, f of 3, I'm going to plug in 3, but watch the order. First, you do the exponent. Yeah. And then you're going to end up with 8. And then you multiply by -1, and you get -8. Let's try another one. So what's f of 2? So you have -1 times 2 squared. Make sure you do the exponential first. So now you have -1 times 4, which is -4. Now, I don't know if you're catching on, but notice, suppose you were not careful. It's a very common mistake. Multiply the -1 and the 2 and get -2, and then try to do this problem again. Yeah? And watch how you're not going to get the right answer this time. Kind of set you up for this one. If you plug in the -2 as the base, in other words, if you combine this together and think of this as -2, and then you square it, you will end up with 4, and this is incorrect. All right. The correct answer for f of 2 is -4, not +4. So be careful. Never include the negative inside the base. All right. There was a little subtlety in the very first definition that I put in this lecture, and that subtlety was the base must be positive. So if you see a negative, that negative must be happening away from the base or outside of the base. The base itself must always be positive, and it needs to be done first. The order of operations says that you do your exponentials before you do your multiplications. Okay, this is going to be our last one today. Example 6. It's the worst one. I saved the worst for last. Find an exponential function, CAX, passing through these 2 points. If neither one of these points has a 0, that means it's going to be a little bit of a chore to solve. Not going to be the easiest problem in the world to solve. So you're going to suffer a bit. Just a little bit. Just enough to get you smart. Okay? Or at least halfway to smart. All right, so what we're going to do is we're going to set up 2 equations. Using each of the pairs of points that we're given. Remember, get rid of your f and call it y, and you'll be a lot happier when you set up these equations. So for equation number 1, I'm going to use the point 1 and 10. It's a little bit out of view there. Let's try this. 10 equals CA1. There we go. So my y is 10, and my x is 1. And I'm going to solve this equation algebraically. In other words, I'm not going to get a numeric answer. I'm going to get an algebraic expression that tells me what C is in terms of A. So this is not a number. This is an equation that we're going to call the substitute. Now we're going to use the other equation by plugging in the other pair of numbers. So we have 2 over 125. That's our y. And then we have CA to the negative 3 power. Remember, x is the exponent. That should be pretty easy to remember. And then y is the same as f. Y is the output or the y value of the function. Now, you don't actually know what C is, but you have a substitute for C. So you can replace the letter C with a substitute, 10 over A. Okay? And now your C is apparently vanished. Yeah, there is no more C. You just have A's. And now you're ready to go. Go ahead and solve this equation for A. I've run out of room here, so I'm going to have to come back up here to the top. So I've got 2 over 125 equals 10 over A times A to the negative 3. Remember, if you don't see a power, that power means 1. You are dividing. You subtract exponents when you're dividing. Why are we dividing? Well, look, the A is in the denominator, so denominator dividing. I hope the reason is clear. So now you have 2 over 125 equals 10A to the negative 4. We're going to multiply both sides by 1/10. That's the same as dividing by 10. Yeah? Multiplying by 1/10 is the same as dividing by 10. So now you're going to have 2 over 1250 equals a to the negative 4. This is where it gets rough. What is 2 divided by 1250? Oh, clearly, Professor, that's 1 over 625. In other words, just divide 1250 divided by 2. Yeah. But don't forget that there's a 1 on top. All right. If you have to, you can use your calculator. There's no shame. Calculators are allowed in this section. You have a to the negative 4, so that's going to be 1 over a to the 4th. Remember from earlier, a negative power means change to a positive and use the reciprocal. I'm going to multiply both sides by a to the 4th. So now I've got a to the 4th over 625 equals 1. Now I'm going to multiply both sides by 625. So now I've got a to the 4th equals 1 times 625. Please don't use your calculator for that. You know what 1 times 625 is. And then remember earlier, if the shoe fits, yeah, it's a 4th power. So you're going to use a 4th root. Use the root that matches the power. All right, now you can use your calculator. You don't have to memorize what the 4th root of 625 is. Although I think it's 5. I would not trust that. I would use my calculator. Oh! And we got 5. 5 was a pretty good guess for any number that ends in a 5. If you have a multiple of 5 that ends in a 5, you know, if you want to guess, it's probably 5. My second guess would have been maybe 15 or 25 or some other number that ended in 5. But don't guess with that. You know, if it's not a simple square root that you learned when you were 12, then use your calculator. Okay, and that's what this class is about. When to use your calculator versus when just to stop and think about it for a second. All right, so we've got our A. I don't know if you remember, I erased it 10 minutes ago, but we still don't know what C is. Remember this guy up here? This guy was our C. C should be pretty easy. C is just 10 over A, and A is 5. So you're done. 10 over 5 is clearly 2. So now you are totally done. You've got your C value, you've got your A value, and so your answer is f of x, that's the original name of the function, is C, so C is 2, times A, 5 to the x power. And remember, do not multiply the 2 and the 5. If you do all this work, you spend a half an hour on this problem, and then you forget that the constant scalar and the base do not multiply together, you'll end up getting a 10, and you've just ruined a perfectly good answer. So it is 2, wait for it, 5 to the x. So the 2 and the 5 are separate entities. They don't multiply together and become 10. So just either use a dot or use parentheses. OK, that's just the introduction to what you're in for the next 4 or 5 lectures of exponential functions. So tune in tomorrow for the second part of this lecture. Bye.